Hi students, welcome to physics class. Today we will discuss about refraction through prism. A prism is a glass material made of crown or flint glass. Here prism has three planes and a prism is of an equilateral triangle. So the three planes are AB, BC and CA. Here AB and AC are called as refracting surfaces. Here N1 and N2 are called as normals to the plane. PQ and RS are the incident and emergent rays. I1 and I2 are called as angle of incidence and angle of emergence. Here, in the case of refraction through prism, light must travel from air medium to glass. Because of change in the medium, there will be refraction and the angle of refraction is given by R1. Again, from glass to air, there is another refraction. So, here R2 is the angle of refraction. So, in a glass prism, there exist two refractions. One is from air to glass and angle of refraction is R1, and another one is from glass to air and the angle of refraction is R2. If there is no any change in the medium, then the light must travel in a straight line, that is in a rectilinear motion. That is, the light must travel, the incident light PQ must travel along the yellow line. Because there is a change in medium and the light undergoes two refractions, finally the light emerges like RS. Here the angle between the actual path of incident light ray and emergent light ray is called as angle of deviation. Angle of deviation is the angle made by the incident ray with the emergent ray. In order to find the refractive index of prism, we have to go through some geometrical properties. We have to apply the geometrical properties to obtain the refractive index of the prism. Let us consider the triangle QRT in the diagram and apply some geometric properties. In a triangle, the sum of the angles must be equal to 180 degrees. So, angle at R plus angle at Q plus angle at T must be equal to 180 degrees. Angle at R is given by R1 and angle at Q is given by R1 and angle at R is given by R2. By substituting we get so finally we get this expression 1. Similarly, we apply the same geometric property in the triangle QRU. Angle at Q plus angle at R plus angle at U. These sum must be equal to 180 degrees. Here we have to apply another geometrical property. Let us consider two intersecting straight lines, pair of straight lines. At the intersection point, the vertical opposite angles must be equal. Here, the two intersecting pair of straight lines in the figure are N1T and PQ. So, the opposite vertical angles must be equal. Similarly, we have another pair of straight lines intersecting with each other. Those are N2T and RS. So, the opposite vertical angles must be equal. Now, we have to calculate the angle at Q in the triangle QRU and the angle at R in the same QRU triangle. We can get these angles by simply subtracting I1, that is by subtracting R1 from I1 and R2 from I2. That is, here the angle is R1. Here the angle must be 2 R. By substituting these values in the above expression, we get and another angle we have to know here is the angle at U. Let us consider the yellow line. It is a straight line which is having an angle 180 degrees. The angle made by the straight line must be 180 degrees. Here, this angle in the figure is denoted as angle of deviation. So, the remaining angle at U inside the triangle must be 180 degrees minus D. That is, total angle is 180 degrees and the angle at U outside the triangle is D. By subtracting D value from the total 180 degrees, we get 180 degrees minus D, which is the angle in the triangle QRU. By substituting this value, we get cancelling 180 degrees, we get given is R1 plus D. This is expression number 2. Similarly, let us consider a quadrilateral QART. In a quadrilateral, QART, the sum of the angles will be equal to 360 degrees. We have to use this property here, and another property we have to know here is that, let us suppose this is a side and we have drawn a normal to this side. Then the angle at this point must be 180 degrees because we have drawn a normal to this plane. Sorry, 90 degrees. Total must be equal to 360. So, we will clearly say that this is 90 degrees and this is also 90 degrees. This is 90 degrees and this is also 90 degrees. So, we are clear that angle at Q is 90 degrees, but R is equal to 90 degrees in quadrilateral QAR. So, by applying these two principles, we get angle at T, which is equal to 360 degrees. Angle at Q and angle at R are 90 degrees. So, angle at A is called as angle of the prism, and angle at T is given by the expression 1, which is equal to 180 degrees minus of R1 plus R2. plus 90, 180, 180 plus 180, 360, and this 360 cancel out. We get R1 plus R2, which is the expression. Now let us consider ID curve. In order to draw an ID curve, we have to take the angle of incidence values on x-axis and angle of deviations on y-axis. Let us draw the outline of a triangle and draw the normals to the two refracting surfaces. Take the angle of incidence as 30 degrees, the angle of emergence, and finally calculate the angle of deviation. Let us simply increase the angle of incidence in the intervals of 5 degrees and calculate the angle of deviations. In each case, and note down these values in the table. Let us say the minimum deviations and the deviation, angle of deviation values corresponding to angle of incidence. For example, 30 degrees for angle of incidence, angle of deviation may be 52. For angle of incidence 35, angle of deviation is 50. For angle of incidence 40, the angle of incidence for which is 30 degrees angle of deviation. Clearly observe angle of deviation decreases, angle of incidence is increased. Or D minimum, and this angle of deviation increases. The angle of deviations corresponding to angle of incidence, and we get the shape of a graph is a parabola. The angle of deviation has minimum point. At this point, angle of incidence must be equal. The two refractions must be equal. Let us say I1 is equal to I2, which is equal to I at angle of minimum so apply this A is equal to then I plus I2 plus R2 plus here we clearly plus D at at R2 is equal to R so is equal to R at dou I1 is equal to I A plus D is replaced by at dou D must be dou therefore I is equal to A plus dou by 2 I is equal to this expression expression substituting I mu is equal to sin by 2 by refractive expression is used to calculate the refractive index of medium of the prism. Here the prism is made of crown or flint glass. Material refractive index can be calculated by using this expression. consider small angled prism is very small. Degrees. Type of prism small angled prism. For small angled prism, plus rho by 2 equal to, by substituting these values, these approximate values in mu, we get rho by 2 by cancelling we get this expression index of small angled prism. Let us consider angle is equal to 48 values in the expression above we get like we get 1 plus 0.62. This is, thank you.